Yo, Code Pilots! Welcome to Part 6 of the Python OOP Masterclass. We've covered polymorphism, and now we're diving into abstraction. This'll be a detailed journey with lots of explanations, so hit that like button and let's get started. Let's unpack what abstraction is and why it's a big deal. Abstraction is all about hiding complex details and showing only the essentials to the user. Think of a car. When you drive, you don't need to know how the engine works. You just press the pedal. In coding, this means creating classes that expose simple interfaces while keeping the messy stuff hidden. It makes code easier to use and maintain, and today we'll explore this with our car theme. Let's talk about why. To get started, let's think about why abstraction matters. Imagine you're building a system with lots of vehicle types: cars, trucks, buses. Without abstraction, users might accidentally mess with internal engine details, causing errors. Abstraction lets us define what users can do, like start or stop, without exposing how it's done. We'll use the vehicle class as a base and add abstraction tools. Let's take a moment to appreciate how this simplifies things before we begin. In Python, we can use the ABC module for abstraction, which stands for Abstract Base Classes. This lets us create a blueprint that forces child classes to implement certain methods. The goal here is to ensure every vehicle has a start engine method, but we won't define how. It's up to the child. Let's import ABC, create an ABC class called vehicle, and add an abstract start engine method. Let's plan this out carefully. Let's build the abstract vehicle class. Use from ABC import ABC abstract method, then class vehicle ABC with @abstract method over def start engine self pass. This tells Python this is a blueprint. Child classes must fill in the details. The reason we're doing this is to enforce a standard across all vehicles. Let's add it and discuss what it means. Before moving on, let's talk about the power here. By making start engine abstract, we're saying every vehicle must have this ability, but the implementation can vary. This protects our code from incomplete designs and makes it more robust. Now, let's test this setup by trying to create a vehicle instance. Spoiler, it won't work. Let's see the error and understand why. Since we can't instantiate vehicle, let's create a car class that inherits from it. Use class car vehicle and implement def start engine self to print car engine starting with a roar. The purpose is to show how a child fulfills the abstract requirement. Let's add this and prepare to test. Let's test the car class. Create myCar equals car and run mycar.startEngine to see the message. This works because car provided the missing piece. Take a moment to see the output and think about how abstraction guides us. Let's also discuss why this prevents someone from using an unfinished class. Let's add a sports car class to see more variety. Use class sports car vehicle with def start engine to print sports car engine revving at high RPM. The idea is to show different implementations while sticking to the abstract rule. Let's set this up. Test the sports car class. Create mySportsCar equals sports car and run mySportsCar.startEngine to see the revving message. This highlights polymorphism within abstraction. Pause to reflect on how both classes meet the same standard differently. Now let's think about a practical use. We'll create a garage class with a method startAllVehicles that takes a list of vehicle objects and calls startEngine on each. This leverages abstraction to manage any vehicle type. Let's plan this out and add it. Test the garage class. Create garage equals garage. Add my car and my sports car, and run garage dot start all vehicles, my car, my sports car. Watch the different start messages. This shows abstraction in action. Let's discuss why this makes the garage code flexible. Let's enhance start all vehicles to check if each vehicle starts successfully. Add a simple condition, like printing a confirmation. Update it. Let's test and talk about how abstraction helps us add features without breaking the system. Test the enhanced start all vehicles. Run it again and see the confirmations. This wraps up how abstraction simplifies complex systems. Take a moment to appreciate the elegance of hiding details. That's a wrap for Part 6, Code Pilots. You've mastered abstraction with car examples. Like this, subscribe, and try applying abstraction in your projects. See you in Part 7. Keep coding